A battery ran at 100 degrees Celsius. Also, the lab report says the pouch lost its vacuum. Congratulations. You've just summoned the two loudest groups on the internet. The internal combustion is dead by Tuesday crowd and the spicy pillow candidate crowd. And almost nobody reads the methods section. So today, we're doing the OsirisPerseus thing. Signal over hype. Not, is this the greatest battery of all time? Not, is this a scam? Just the reality lens. What does the test prove? What can it suggest? And what does it absolutely not prove? Because one third-party report can be both real and misleading at the same time, depending on what you think it's claiming. Here's the one-sentence mystery. A customer-supplied cell, identified by the customer as a solid-state battery cell, was discharged at extreme heat. At plus 80 degrees Celsius, it delivered more capacity than at plus 20 degrees Celsius. At plus 100 degrees Celsius, it also delivered more capacity than its plus 20 degrees Celsius reference. Then afterward, the pouch was observed to have lost its vacuum. That last line is doing more plot work than half of Netflix. And the funniest part is the marketing language collision. Some people hear comfort zone. Physics hears my brother in Christ. That's a Finnish sauna. So let's go step by step. Because the truth usually lives in the boring details people skip. Chapter 1. Independent test. Independent of what? First, what is this report? It's a customer report from VTT. That matters because VTT is a real third-party test lab, not a YouTube comment thread with a multimeter. But also, third-party test does not mean third-party verified every claim you've ever made. This is the part where hype sneaks in through a side door. The report explicitly says they tested a device supplied by a customer, and the customer identified it as a solid-state battery cell. That means the lab is verifying performance under a specific protocol. They are not, in this document, doing chemical forensics on the inside and declaring, yes, this is definitely chemistry X with architecture Y, and it meets everyone's personal definition of solid state. So if someone says, independent lab confirms its solid state, you should mentally add a footnote. Independent lab tested a customer-identified device. That's not nothing, it's just not everything. Here's a clean clip line. Independent testing is about the protocol, not the mythology. Now, why does that still matter? Because the protocol is the whole point. This isn't a render. It's not a vibes-based animation with dramatic music and the word revolution pasted over it. It's a narrow test that produced a narrow result. And narrow results are powerful, if you don't hallucinate what they mean. So our job is to keep the claim space clean. What was actually tested? What conditions were used? And where are the edges of the box? Because if you stay inside the box, you can be confident. If you step outside the box, you're writing fan fiction. And I like fan fiction. Just not when it's pretending to be engineering. Chapter 2. What VTT actually did. Okay, what did they actually do? The core shape of the test is simple. Charge at plus 20 degrees Celsius using a standard constant current, constant voltage method up to 4.15 volts. Then discharge at a target high temperature down to 2.7 volts. Important detail. Charging was consistently performed at plus 20 degrees Celsius. That's not a minor footnote. That is the difference between high temp discharge performance and high temp operation. Because charging at high temperature is often the harder, riskier, more failure-prone part of the story. So if you're tempted to say, this battery operates at 100 C, reality taps the sign. It was discharged at 100 C. It was not charged at 100 C in this protocol. Now the two high-temperature runs. One, discharge at plus 80 degrees Celsius using 24 amps. And one, discharge at plus 100 degrees Celsius using 12 amps. The report also describes a physical setup. The cell sat on a heat sink in a climate chamber, and a heavy steel plate was placed on top to provide mechanical pressure. That matters because otherwise, viewers imagine a naked pouch cell free-floating in a blast furnace like it's doing a TikTok challenge. No, it was tested in a controlled setup with mechanical constraint and thermal contact. Now the numbers people are fighting over. At plus 80 degrees Celsius, the reported discharge capacity was about 110.5% of the plus 20 degrees Celsius reference at the same discharge current. At plus 100 degrees Celsius, the reported discharge capacity was about 107.1% of the plus 20 degrees Celsius reference at that discharge current. So yes, under those conditions, it delivered more measured capacity when hot. And that part is not weird, actually. Many battery systems show reduced internal resistance and improved kinetics when warm, which can make discharge look better, at least short-term, especially compared to a cooler reference. Here's a clean clip line. Heat can make a battery look stronger right up until it makes it look dead. That's why we don't stop at the headline, because the headline is where your brain gets tricked into thinking more capacity equals more safety, or more durability, or new physics. Not necessarily. This is one cell, under a specific protocol for a small number of cycles in a chamber with a pressure plate. It's a real data point. It's not a lifetime verdict. Chapter 3: The Loss of Vacuum and the Birth of Lore. Now we reach the sentence that launched 1,000 memes. After the 100C discharge, the lab observed the pouch had lost its vacuum. What does that mean? The honest answer is, this report alone does not give us a full diagnosis. Lost vacuum is an observation about the physical state of the pouch. It suggests a change in the packaging condition, but it does not automatically equal catastrophic swelling, and it also does not automatically equal totally fine, nothing happened. It's a yellow flag, and the only correct move with a yellow flag is ask what test would turn it green or red. So let's list hypotheses, explicitly as hypotheses. One possibility is a seal or packaging issue. The pouch seal could have been stressed by temperature, pressure, or cycling and no longer maintained its original condition. Another possibility is gas generation. The extreme temperature could have driven some outgassing, and the pouch condition changed as a result. Another possibility is a mechanical interaction. Under heat and pressure, layers or materials might shift in a way that changes the pouch's internal pressure state. And yes, another possibility is mundane. Interpretation differences or measurement detail we can't see from the summary alone. The point is, lost vacuum is a clue, not a conclusion. Now, let's do comment section court. Claim 1. This proves it's safe at 100 degrees Celsius. That's a red stamp. Because safety is a whole field, abuse tests, thermal runaway behavior, repeated cycling, failure modes, and what happens when things go wrong, not just whether one discharge completed. Claim 2. This proves it's fake solid state. Yellow stamp. Because you can't declare internal chemistry from a performance report without direct analysis. You can raise questions. You can ask for independent chemistry verification, but case closed is vibes, not evidence. Claim 3. This is impressive and raises new questions. Green stamp. Because that's the adult response to an unusual result with a weird physical note attached. Here's another clean clip line. If your conclusion is stronger than the method, you're doing marketing. And speaking of marketing, when a company says comfort zone and the lab report says lost vacuum, You don't need to pick a team. You need to pick a checklist. Because the future is built by people who can hold two ideas at once. This is interesting, and this is incomplete. Chapter 4: The Scoreboard and the Next Receipts. So what do we do with this? We build the scoreboard. What this test supports: it supports the narrow claim that this specific cell under this protocol could be discharged at plus 80 degrees Celsius and plus 100 degrees Celsius while delivering higher measured capacity than its plus 20 degrees Celsius reference measurements. That is real. That is weird enough to be worth attention. And it's definitely more than nothing. What this test does not support: it does not support claims about long cycle life. It does not support claims about energy density. It does not support works as a vehicle pack. It does not support high temperature charging is fine because charging was done at plus 20 degrees Celsius. And it absolutely does not answer the safety story. Now, the three receipts we need next. Receipt 1: repetition. Multiple cells, multiple batches, repeated high temp discharge runs showing the same behavior without physical changes. Receipt 2: high temperature charging tests. Because discharge is one side of the mountain, charging is the cliff face. Receipt 3: failure analysis of the vacuum loss. Photos, thickness measurements, mass change, gas analysis if applicable, and a clear explanation of what lost vacuum means in this context. Now let's do the outcome ranking, clearly as scenarios, not predictions. Best case: the vacuum loss is an edge case packaging issue, or a one-off. The behavior repeats cleanly across many cells, and high temp charging plus longer cycling shows minimal degradation and stable mechanics. That would be legitimately world-changing. Most likely, the high temp discharge improvement is real but comes with constraints, and extreme heat creates mechanical stress that has to be engineered around. It becomes a specialized advantage, not a replace everything tomorrow miracle. Worst case: the vacuum loss repeats, correlates with gassing or degradation, and the test ends up being a spectacularly photogenic stress demo that doesn't scale to real-world packs. Here's the final lesson. One graph can be true and still be a trap, because the trap is not the data. The trap is the story people tell themselves on top of the data. This is how we avoid getting hypnotized by a single result. We keep the claim inside the box. We demand the next receipts, and we update when the evidence updates. Signal over hype. Subscribe to join the expedition.